Alright, today we are going to do section 1.4, which are equations of lines and modeling. We started talking about linear equations or linear functions on Wednesday, and that's kind of where we're starting today with a little slight review of Wednesday. Oh no, there's an answer. Don't look. So on Wednesday we talked about the slope-intercept form, and I gave it to you in f of x equals mx plus b. Today we're going to leave it as a y equals mx plus b. So remember that the m represents your slope, and that b is your y-intercept. The y-intercept is where your line crosses the y-axis. So you can give that as an ordered pair. It's a 0, b. Some of your equations will be to write the equation of a line. Here's a good rule or tip as you go throughout any of your math classes, or especially this one. If you are asked for the equation of a line and it doesn't tell you what form to give it in, it always wants it in the y equals mx plus b form. So if you get a line started and it's in any other form, like you'll see later on today, you are not done with that line until you get it into y equals mx plus b. All right, but this first example is very straightforward. It's very much a plug and chug. It says we have a line that has slope negative 2/3 and contains the y-intercept 0, -3. Give the equation. So it gives us the slope, it gives us the y-intercept. So we are able to write the equation from that. Y equals negative 2/3 x minus 3. We have it minus instead of a plus because the y value itself was negative. I remember the y equals mx plus b was one of those equations that I told you is very good to memorize. If you're keeping a running list or a sheet or anything like that, that's definitely one you want on your sheet to memorize. The next formula or form of a line is another one you're going to want to memorize or include on your sheet. This one is called the point-slope form. So the first one is slope-intercept, where you have your slope and your y-intercept. Point-slope form is where you have any given point that lies on the line and the slope of the line. So this is y minus y1 equals m times x minus x1. Once again, the m represents our slope, but this x1, y1 that we see in there is actually a point on the line. The x and the y in this form that do not have that subscript of a 1 are the variables for that equation. There are generic x and y. The x1 and the y1 are the ones we replace with the values from the point that lies on the line. Slide it up. Because we're going to do an example. And this one it does tell you, it says find the slope-intercept form for a line with a slope of 4/15 through 5/8. So it even tells you it does actually want you to get to slope-intercept form, but that's not where we're going to start. That is our ending point. Y equals mx plus b is where we want to get to. But what we have to start with is we have our slope, which they told us is 4/15, and we have this ordered pair of 5/8 that we know our line is going to go through. So we have our slope and we have our point, so we're going to use point-slope form because this is x1 and this is y1. Remember, anytime you're using a new form that you're not used to or it's been a while, I recommend writing it down because then it really becomes a plug and chug style problem. We have y minus y1 equals m times x minus x1. The y and the x without the subscripts stay, so it's just y minus, and then our value for y1 is 8, equals m, well our m in this case is 4/15, times x minus our x1, which is 5. Now, this does not look like y equals mx plus b, so we're going to have to do some algebra to get it there. So what would we do first? Yeah, we got to distribute this 4/15 inside of our parentheses. So y minus 8 equals 4/15 x minus 4/3. We have 4/15 times a negative 5. Yep, 4/3. We still need to get y by itself, so we're going to add the 8 over. So y equals 4/15 x. And then if we're adding 8, but we need to have a common denominator of 3, that's like adding 24/3. So we're going to plus 20 over 3. Fractions are your friend. Do not shy away from them. They're not going to go anywhere. Does that mean I'm always going to give you like the problems that have like the really hard fractions in it? No, but you do need to be comfortable enough to be able to add a whole number, convert it into a fraction, so that you can add and subtract with that. If you need a refresher on that, if fractions are something you know you generally struggle with, on the YouTube site where I post our lecture videos are also all of my lecture videos from Math 20, excuse me. And in Math 20, we spend all of section 1.3 going over a big review of fractions and how we add, subtract, multiply, and divide them. So there's some good material there if you need to go back and just get like a quick refresher. Also, on my YouTube site, I also have all of my, I have maybe 90% of that one done, but all of the lecture videos I had made when I was teaching at Pitt State are also on there when I taught college algebra. Obviously, their textbook is different than your textbook, so it moves through it in a slightly different manner. But if you just need extra resources and extra practice and seeing extra problems worked out, those are a great resource as well. Again, 1.4 and the Pitt State videos is not going to necessarily coordinate with 1.4 in ours, so you would have to kind of go searching for things. But in case you do ever get stuck and just need to see me work through other problems, those are a great resource. And they're on the same YouTube site that these videos are. So, just so you know. Any questions on this one? All right, let's do another one. Find slope-intercept form for a line containing the points 2, 3, and 1, negative 4. So again, our end goal is the y equals mx plus b, but this time it gives us 2 points. It doesn't give us slope. It doesn't give us anything else. So what do you think we need to do first?
Find slope.
Yeah, we got to find that slope. How do we find slope? Who remembers? I'm here. Yep. y2 minus y1 over x2 minus x1. Again, it doesn't matter which of these ordered pairs is your point 1 and your point 2. In general, I go with the order that they have it written. So I would have this as my point 1 and this is my point 2. So y2 then would be negative 4 minus my y1, which would be 3, all over my x2, which is 1, minus my x1, which is 2. Negative 7 over negative 1 equals a positive 7 for my slope. And there it is in the notes too. Now that we have our slope, and we have 2 points, we can use our point-slope form. Now, it does not matter which of these points you decide to use as your x1, y1. It works either way. In the notes, it looks like I went with this point. So if you want to see that it works either way, you guys can use the point 2, 3, and you'll see that it works exactly the same way. But this is y minus y1 equals m times x minus x1. y1 in this case would make that into a positive. We have 7 times x minus 1. We're doing the exact same process we did on the last problem, only now we have nicer numbers. We don't have our fractions. Distribute our 7. Subtract that 4 over. And you get y equals 7x minus 11. Questions? Yes? That is your point slope form. You have to have a point and slope for that one. So in this case, we didn't have slope. We had 2 points. So we used those 2 points to find slope. And then we used one of those points with the slope. If you were to use the other point, the 2, 3, you would get the exact same answer at the end. So it does work.
Is that necessary? Like if you were to use the y would that still be correct? Or
you can't use y equals mx plus b because it didn't give you the intercept. The intercept is a very specific point, and you can't use that because that's not what they gave you. If you were to actually graph it and then you found the intercept, you could do it that way, but that's a little bit more work too.
like if we were to plug in that, like say we were plugging like negative 4, like where the y would be, and the 7 where the x would be, and that
Nope. It doesn't work because those are not variables that we are plugging in for. So the reason why we can plug into this one is it's the x1 that we are substituting for and the y1. The x and the y remain. That's why at the end we still have a y and an x. Those are just part of the equation. Okay? Good questions though. Okay. So we are dealing with slope today. A lot today. So there's different kinds of slope. And from the slope, we can tell whether or not 2 given lines are parallel or perpendicular. Now, parallel lines are lines that run parallel to each other. Maybe you're like, okay, that's helpful. Parallel lines run side by side, and they're never, ever, ever going to cross. Parallel lines are like, if you're from Joplin, it's like our numbered streets. 7th Street and 20th Street are never going to cross. Why? Because they run parallel to each other. They're never going to cross. Parallel lines have slopes that are the same. That's what makes them not ever cross, is because at the same rate that this top line is moving up and over, the bottom line is moving up and over at the exact same rate. So it's just going to run right alongside of it, and it's never going to actually cross it. Perpendicular lines cross, but they cross in a very specific way. When they cross, they make these right angles, these 90-degree angles. This is like 7th and range line, okay? When you go to 7th and range line, you have to make a very deliberate right or left turn to turn off of 7th Street onto range line. Murphy is all kinds of wonky and runs all the way through town. It is not perpendicular because it does all kinds of curves. You can turn off of 12th or 15th Street onto it in all kinds of different ways because it's all kinds of weird. It's not perpendicular. Perpendicular makes these really nice, crisp corners like 7th and range line does. Perpendicular lines have slopes that are negative reciprocals. Okay? What that means is you can flip it and you change the sign. That's a negative reciprocal. Okay? Parallel lines have slopes that are the same. Perpendicular lines have slopes that are negative reciprocals. And here's some pictures. Because in your homework and in your quizzes, you're going to be asked to identify whether a set of lines is parallel, perpendicular, or neither. So like I mentioned on parallel, they run side by side. The symbol for parallel is underneath the word parallel. Perpendicular, they make those nice, crisp 90-degree right angles. And the symbol for perpendicular is right below that. It looks like an upside down capital T. Then there's also the option for neither. Neither is like Murphy Street. Murphy Street intersects with all kinds of other streets, but it doesn't do so at a nice, crisp 90-degree angle. And so that's neither. It's neither parallel nor perpendicular, but the way it does intersect. And the nice thing about parallel, perpendicular, and neither is most of the time the only thing you need to get is you have to just figure out the slope of the line that you're comparing it to. Because parallel lines have the same slope, perpendicular lines have the negative reciprocal slope. And if you're not either of those situations, then you're neither. It's kind of a, are you this? No. Okay. Are you this? No. Then you know you're this, is how it works. So the first example says we're going to find the slope of a line parallel and a line perpendicular to this equation of y equals 3x plus 2. Sorry. And we're not finding an equation. It just says find the slope. So what you need to discover or figure out first is what is the slope of y equals 3x plus 2? What is that slope? Because that's kind of our starting point. 3. Our slope is 3 because this is y equals mx plus b. So then what would be the parallel slope to that? 3. That's right. Parallel slopes are the same. And then what about perpendicular slope? This is the negative reciprocal. Negative 1/3. The way you find that is you look at the original and say, okay, I need to flip it. But this is a whole number. So you can think of it as 3 over 1. So then if you flip 3 over 1, it becomes 1 over 3. But it's the negative reciprocal. So the signs have to be opposite. And that's how you get there. So here's some helpful hints. I don't think I actually wrote them out. No, I didn't. Here's some helpful hints on how to quickly identify whether or not two slopes are parallel, perpendicular, or neither. If your two slopes are the exact same number, they're parallel. That's the only time they're parallel. If you have two slopes that are the same sign, so they're both positive or they're both negative, but they're not the same number, automatically it's neither. The only thing that doesn't work for that is negative 1 and 1. Negative 1 and 1, they're kind of like special. No, those aren't the same sign. Is it 1? No, it all works. Yes. Yes. So if the slopes have the same sign, but they're not the same number, they're neither. Because if you have perpendicular slope, you have to have opposite number or opposite signs automatically. Yes.
So like if it's like 30 negative 1/4, that just wouldn't.
Right, that's a neither situation.
Okay.
Yeah. So whenever I look, like if you're given two slopes, which I thought maybe I did this, but I guess not, I skipped it. But here's a good, if you have slope 1 equals 3 and slope 2 equals 6, are those lines parallel, perpendicular, or neither? Neither. Because the only time the signs can be the same on your slopes is if they are the same. Otherwise, it's neither. So if I had slope 1 equals 3 and slope 2 equals negative 1/3, we already said those are perpendicular. And so if I had slope 1 equals 1/4 and slope 2 equals negative 1/4. What's that? It's neither. Yeah, so the signs aren't the same. So we know it's not parallel. It's not the same number. So that's not. But the signs are opposite, but the numbers aren't reciprocal. So that's how we get to neither. So some of them will be just that. It'll give you two slopes, or it'll give you two equations, and it asks you, is this parallel, perpendicular, or neither? You figure out the two slopes, and you compare them. Okay? All right. Here's another example. Let me get a clean sheet of paper so you don't have to look at all the scratch. It says, write the equations of the horizontal and the vertical lines that pass through the points -2 and -3. On Wednesday, we talked about horizontal lines and we talked about vertical lines. And we said that horizontal always look like y equals b, and vertical lines always look like x equals a. So we need to write equations for the horizontal line that passes through the point -2, -3. What's that going to look like? Oh, just speak up. You don't have to raise your hand.
Is this the horizontal one?
Yep, let's do the horizontal one first.
Is it y negative?
That's exactly right. Y equals -3. That's the only horizontal line that's going to go directly through that line at the point -3. So then what is the vertical equation? Or the equation of a line that runs vertically through the point -2, -3. X equals -2. Don't make it hard. I know it's kind of a weird wording or weird question, but what it really is doing is if you were to plot that point, -2, -3, it's right down there. We need to put a vertical line through there. Well, where would that happen? It would happen at x is -2, and we need to put a horizontal line through there. Where would that happen? It would happen at y equals -3. Okay. Let's do another problem. We're going to find the linear function for f, given that f of 7 is -19. And f of -4 is 25. So it wants the linear function, and it wants you to find f of 1. Now, it makes it look and sound a whole lot scarier than what it actually is. Okay? The linear function is what we talked about on Wednesday. That's f of x equals mx plus b. It's our slope. It's our slope-intercept form of a line. That's all the linear function is. So we're finding the linear function given that f of 7 is -19 and f of -4 is 25. Now remember, this f of 7 is -19. Well, notice, look what's inside. It's f of x. That means 7 is the x value, and -19 is the y value. That's what that is telling us. And the other f of -4 is 25 is telling us our other point. So really, this information that they gave it to us in a completely different format, but it's exactly like a problem we did just a little bit ago where we had 2 points. And we need to come up with the y equals mx plus b form of the line that goes through those 2 points. So what did we have to do first on the last one that we did like this?
Find a slope.
Yeah, we had to use the 2 points to find the slope. We're going to do that exact same thing. So y2 minus y1 over x2 minus x1 46 over negative 11. Is it really that gross? No, not if I can do numbers right. Goodness, 44. I can't do numbers. It's late on a Friday. And if it was Monday, I'd say, oh, it's early on a Monday. And if it was Wednesday, I'd say, it's Wednesday. Math is just hard sometimes. Yeah, that's when math is hard sometimes. All right, so we find the slope, and we have these 2 points. So we can use either one of those points and put it in our point-slope form and simplify it down. I'm going to use the bottom point. I don't know if that's what I did in my notes, but that's what I'm going to do this time. Y minus y1 equals m times x minus x1. Distribute that negative 4 and add the 25 over. That's not the one I used in my notes, so that's good. You have both examples. This is a great opportunity for us to see that in my notes, I used the 7, negative 19. And here on the paper in class, I used the point negative 425. But both of those ends up in this y equals mx plus b. That's exactly the same. Y equals negative 4x plus 9. So that is the linear function, or I guess if it's linear function, it's f of x equals negative 4x plus 9. But now the question that they left us with is, it says, then find f of 1. So we're not totally done yet, because we have to find f of 1. F of 1, that means anywhere there's an x, we're going to put a 1. So f of 1 is 5, because negative 4 plus 9 is 5. So sometimes they have you do a similar problem, but they word it differently. So if they word it differently, don't freak out on it. Just look at the information that they give you and figure out what they've actually given you. That problem, even though it said f of 7 equals negative 19 and f of negative 4 equals 25, they gave you 2 points. You use the 2 points, you find your slope. Now you have a slope. Use one of those points, you can get there. Questions? Okay, we got one more big problem, and then you guys are done. We're going to do a word problem, because that's everybody's favorite way to finish class on a Friday. And you may not want to write all of it down, because that's a lot of stuff. It's all to deal with scatter plots, which can be found in your textbook on page 52. I will go ahead and tell you, we will do very little with scatter plots in this class. Yes, it's a great way to examine data, but we don't have time to do that. If you want to do a lot with scatter plots and data analysis, go and take statistics and all that, those other classes that are there. What we're going to do, and what your I think there's 2 questions of scatter plots. What you're going to be given, let me show you a general. You'll be given 2 different graphs, because it's 2 different questions. And one of them will look like this. And one of them will look like this. Do you see how there's dots? Those are scatter plots. So they don't connect using a line or anything like that. That's what makes them a scatter plot. So your questions will be on your homework. For this one, does this scatter plot represent a linear function? It doesn't. It doesn't make a straight line because we've got, if we connected our dots, we get like a swoosh. So it does not. Does this one represent a linear function? Yeah, if we connected those dots, we'd have a straight line. Okay? Those are literally the two questions you have on scatter plots. I'm not spending a lot of time on them because I think you can look at them and tell whether or not they line up and make a line. Okay? I have faith in you guys. You can do it. Now, the word problem, though, is a word problem, so we're still going to do the word problem. All right. This is from your textbook. It will be after page 52. I'm not sure the exact page. But it gives you a chart, and it shows the cost of tuition at a certain state university. And then it gives you the data that you need. So I've made the chart. Here's the college year, and it says the X, and it tells you the estimated tuition, which is your output. So from 1997 to 1998, the estimated tuition at this university was $9,427. And then it shows you the next year, and the next year, the next year, the next year, and so on and so forth. And it says predict the cost of the college tuition in the year 2008 and 2009. Because our table runs out at 2001 to 2002. It stops. So we need to be able to figure out what is happening to our college tuition later on. Well, here's the nice thing, is it tells you a lot of information. It gives you two different points. It says use these 2 points from the chart. So you have 2 ordered pairs, even though they're kind of weird numbers. You have 2 ordered pairs. We need to figure out what is changing. How much is tuition changing every single year? Tuition changes at a, hopefully, a pretty constant rate is what we're going to figure out. And if it's changing at a constant rate, that constant rate is our slope. Yeah.
When like you set up like in y equals x plus 2, like you just use the b then 9,000
You could. Is that what we do? No. I think that's what I tried to do the first time I worked through it. And we can't use that quite because we have to use the ordered pairs that they give us. So we have to use the ordered pairs in order to find the slope, which tells us the rate of change from year to year in the tuition cost. And then from that we can derive what it's going to be later. Because I think I tried to do that, and I think this problem actually aggravated me because it didn't do what you just said it should do. But yes, in theory, you could do that. So what we did is we find the change in tuition from year to year, which is our slope. How did we do that? We used the points that they give you. Okay, the points that they give are the 11,235 as our y2, and our y1 is the 9959. And then we use 3 minus 1 gives you 1276 over 2, which is $638. So based on this university and based on this data, that means tuition is going up $638 every single year. And if it continues on that trend, we should be able to predict then what the tuition is going to cost in any given year. Well, how do we do that? Well, we're going to figure out the equation by using one of those points that they gave us in the slope that we just found. So I used the first or the second point, that 3, 11,235. I plugged that in for my y1. I plugged the 3 in for my x. And that's 368 that we just found. Distribute, combine like terms, and get it written as y equals 638x plus the 9321. Now, based on this, I can figure out how much tuition is going to cost in any given year. Obviously, we are assuming that tuition only rises by $638, and it does so every single year. There is some assumptions that have to be made to make this real-world problem actually work. So one thing, though, that I wanted to make sure I was really careful on is that I identified what my x actually was going to be for that given year of schooling. So I continued on with my data. Up here, it said 97 to 98, that's year 0. 98 to 99 was year 1. And I just continued that on so that I can identify 2008 to 2009, that's year 11. Because sometimes when I do years, I get it mixed up. Maybe you don't mix anything up. You don't have to do that. That's fine. I would have mixed it up. So I went ahead and kept writing the calendar years with their associated X value next to them so that I know to plug in 11 for my X. Now, could you circumvent on this problem and just keep adding 638 every year until you get to the year 2008 and 2009? Sure, you could. Am I going to know that you did it that way instead of doing it this way? No, I'm not. Unless a question like this were to show up on a test, I wouldn't know if you did that. But what you can see here is that by the year 2008-2009, now tuition is costing $16,339 instead of the $9,427 that it cost in 1997. So pretty decent little increase at that university over time. Probably not totally unrealistic. Only it's probably even worse than that. Are there any questions on how we do slope, point slope, how we find slope, how slope indicates parallel versus perpendicular lines, all that kind of stuff? All right, theoretically, that is the end of 1.4. I put on the back that I would do homework problems. If you guys would like me to do any homework problem examples, I am more than willing to do that.